Hello, welcome back to Statistics and Mathematics YouTube channel. Today I'm going to start our studies on how to calculate critical values for our z distribution when one tail or two tail is being given to us with a given alpha. So that's what mainly we are going to discuss today. So this is Statistics and Mathematics YouTube channel. If you haven't subscribed to this YouTube channel, please kindly make sure that you subscribe, like and share so that this video will get viral for friends to also have in touch with this video. In our last video we discussed something on hypothesis testing, the types of hypothesis testing and forms of hypothesis testing. So please, if you haven't watched videos on that, kindly go back and watch before you start this video on calculating critical values. So this is the question. It said find the critical values for each situation and draw the appropriate figure showing the critical region, assuming it is normally distributed, right? But first thing, what I want you to note is that since it is normally distributed, I'm going to use what we call our z. But if it is one tail test and it is tail to the left, we are going to have negative z subscript alpha, and tail to the right, we are going to have negative z subscript alpha. But when it is two tail, we are going to have z subscript alpha divided by 2. So this is how it's going to be, right? So here our question A is just a left tail test when our alpha is given as 0.01. So if our alpha is given as 0.01, then we have to draw our diagram. Since our alpha since it is a left tail test, it means that it will be at the critical value will be at the left section, right? So here we are going to draw it nicely, normal distribution nicely, and this one will be our critical region. That's negative z subscript alpha, right? And then all the regions that you see here will be our alpha. So here we're going to have our alpha to be 0.10. And then here this part is called rejection region, and this part is called the acceptance region or fail to reject region. So the fail to reject region is 1 minus alpha. So when you subtract alpha from of 0.1 from 1, we are going to get 0.9, right? So the 0.9 is the fail to reject region, or better still, that's the acceptance region. So here all that you have been asked to do is to just calculate for our negative z subscript alpha, right? When you do everything very well, we are going to get our negative z subscript alpha to be negative 1.285. But how can one get negative 1.285 unless we go straight to the table to do that? But before that, let's go through some small calculations here before we go to the table. We know that our alpha is given as 0.10, right? And then so here we are going to just get z subscript 0.10. So we are going to just calculate or find our z score from the z distribution table. And note, when we are treating the normal distribution, I told you that once we have z subscript, here is supposed to be negative. Once we have z subscript, let's say alpha, that one is in the negative region. But if you want your z score to be in the positive region, we are just going to subtract 1 from the alpha. So here it's supposed to be 1 minus alpha here, right? So that we are going to get 0.9. But here, since it is a left tail, it falls in the negative regions. So you are not going to subtract it from 1. We are not going to subtract alpha from 1. We are just going to take our 0.1 as our probability, go straight to the z table, and then just calculate for our z score, of which I've teach you how one can calculate this one. So if you haven't watched the videos on this, kindly go to the normal distribution section and then watch this video in order to get the understanding of this, right? So let's go to the table and learn how to find our z score. So this is our z table. So we are going straight to the negative z table since it is still to the left, right? As you can see, example here is it just still to the left. So you are going to straight to the negative table. So this is our negative table. So you are going to locate a probability of 0.1, and then the probability of 0.1, we are just going to look through this probability to get our z score, right? So when we come here, you could see that the 0.1 lies between 0.0003 and 0.985. So it means that our probability, sorry please, I'm coming. it means that our probability is just lying between 0.1003 and a 0.0985, right? And then since we learn from the normal distribution, we just trace it to the row section and trace it to the column section, and just here to be negative 1.2 plus 0. You see, once you trace this one to the top, we are going to get 0.08 and 0.09. We are going to find the average of that. That's 0.08 plus 0.09 divided by 2, right? So when you do the necessary calculations, we are going to get our answer. So let's go to our worksheet to solve that question. So this is how it will be, right? So this is how, if you solve it correctly, you are going to get negative 1.285, right? So that's our critical value for z subscript alpha, right? This is equal to z subscript alpha, negative z subscript alpha. So when we come to the table here, we are just going to replace the negative z subscript alpha to be negative 1.285. So here we are just going to clean this one and then just write negative 1.285, negative 1.285. So this is how you are going to find your left tail test when our alpha is given at 0.10. So let's go to our next question. Our next question is that a two-tailed test with an alpha being given at 0.02, right? So we have been asked to find a two-tailed test with an alpha given 0.02. That's our critical value. So we know that for two-tailed test, this is how the diagram for two-tailed test will look like, right? This is how the diagram from two-tailed test will look like. We know that our alpha here was given us 0.02. So when we ask, then in our previous in our first example we saw, we just say that this section, the rejection region, will be equal to the alpha. So why is that we are having alpha of 0.02? That here when we come to the rejection section, we are having 0.01. Note that this is a two-tailed test, right? We are just going to divide our alpha by 2. So once you divide our alpha by, you're going to get 0.02 divided by 2, which is giving us 0.01, right? 0.01. So here, when we come here, our rejection region, that which was our alpha divided by 2, will be giving us 0.01 and a 0.01, since it's a two-tailed test. So this is how the diagram is going to be for the two-tailed test. We will be having one to the right and one to the left, right? So we are going to learn how we can calculate our critical value for our two-tailed test when our alpha is given at 0.02, right? But first, what you have to do is to write this one. So here we are going to have z subscript alpha divided by 2, and our alpha is given at 0.02, of which when you divide, we are going to get z subscript 0.01, right? Z subscript 0.01. And then you see in our first example, I told you that, guys, that since it is scaled to the right, since it's scaled to the left, we are not going to subtract anyone from any, like we are not going to subtract our alpha from 1. But here it is our z here is positive. Our z here is positive. So for us to go straight to the positive table to locate our probability of 0.99, right, we just have to subtract our 0.01 from 1 to get z subscript 0.99, so that we go straight to the positive z table. So here, since we have a probability of 0.99, we are going straight to the positive z table to calculate for our z score. And by the end of the we are going to get our z score to be 2.33, right? So let's go to the table and learn how we are going to find our probability, our z score, when our probability is given at 0.99. So here we are locating positive z table, right? So here, there is a positive z table, and through the probabilities, we are just going to locate where we can see 0.99, right? So 0.99, you could see clearly that our 0.99 lies, our 0.99 lies between this and that. Our 0.99 lies between 0.9898 and 0.9901. So it means that it's lying between this one, right? So you are just going to trace this to the top and trace it to the row section. You are going to get 2.3 plus 0.02 plus 0.03 divided by 2. When you do the calculation very well, you are going to get 2 points. Let's go straight to the table to work it out. Sorry, let's go straight to the worksheet to work it out. So when you come here, we are going to just get 2.33, because if you have 2.3 plus 0.02 plus 0.03 divided by 2, we are going to get 2.3 plus, this one is going to give us 0.05 divided by 2, of which we are going to get 2.3 plus 0.025. When you add this one to that, we are going to get 2.325, and when you run it to that, we are going to get 2.33. right? So this is how we got our 2.33. So this is the positive critical value, right? And if you want, that's to the right section. If you want the left section of the negative one, sorry, the negative section, we are just going to negate the positive one. So the negative z alpha divided by 2 is equal to just negating our z subscript alpha, right? So we are just going to negate our 2.33 to get the negative section, right? So here, when we come here, we are going to get our negative z subscript alpha to be 2.33, and then z subscript alpha to be, sorry, here to be negative 2.33, and here is going to give us 2.33. So this is how one can be able to find the critical value when it is a two-tailed test. So what about in our last question? Our last question talks about a right-tailed test with an alpha given as 0.005, right? So this one I'll give it to you as an assignment. So kindly solve and share your answer in the comment section. This is Statistics and Mathematics YouTube channel. Please, if you haven't subscribed, make sure you subscribe, like and share so that this video will get to your friends for them to also watch it. Bye. Have a fruitful day.